What we have done so far is did the Wilson Sommerfeld quantum conditions and got some results. More importantly, we have also discussed quite in detail the correspondence principle that led to guessing and deriving quantum mechanical results. And when I say quantum mechanical results, I would mean the quantum number n is small from the classical results n tending to infinity. And we could get some answers. The question still arises that quantum mechanics is not complete. We do not know how to do quantum calculations themselves. And that's where Heisenberg comes and gives his first paper, which has also been called the magical paper of Heisenberg. I'll give that reference, I'll upload it on the forum and you can read it. He says that if you want to describe a quantum system, do not refer to classical physics, do not try to this extrapolation and all that, but calculate quantum mechanical things directly. So that is going to be the topic of discussion today, Heisenberg's paper on quantum mechanics and how he used correspondence principle to come up with the quantum version of the whole theory. So let us see what happens. So far what we have seen, when an atom radiates, and by atom I mean a general quantum mechanical system, it radiates according to, suppose it's performing simple harmonic motion, then I would say that it has some coefficient or amplitude c tau e raised to I tau omega n t. This is how its motion looks, and the general motion is equal to summation over tau of this, where omega n is the frequency partial E partial j corresponding to nth level. Heisenberg asked the question, do we really see the trajectory of an electron or a quantum particle which is radiating in an atom? And the answer is no, I do not really know which way is the electron moving. So it is not proper to talk about things that we do not observe. And his first proposal 1 was formulate quantum theory in terms of quantities that we observe. Historically, this thinking has been historically was inspired by a remark by Einstein in a seminar. So he says formulate quantum theory in terms of quantities that we observe in an atomic system and remain as close to the classical as possible, make minimum changes. So what he proposes is, I'm going to go back and forth between classical and quantum. Classically, we had xt is equal to summation c tau e raised to I tau omega for the nth level t, where these are the amplitudes. This is xt, and which xt is real, and this implies that c tau should be equal to c minus tau star. How do we see that? To see that, write xt is equal to summation tau equals minus infinity to infinity c tau e raised to I tau omega n t, and I can write this as c tau e raised to I tau omega n t plus c minus tau e raised to minus I tau omega n t summed t tau equals 0 to infinity, because now it covers both plus and minus, and for this to be real I should have c tau equals c minus tau star. Not only that, if I do that, and right now let's just consider c tau to be real, then I have xt equals 2 c tau cosine of omega n tau t summed over tau equals 0 to infinity. So the amplitude, if the real cosine tau omega n t is taken, the amplitude of motion is 2 c tau. Alright, that is the classical result. Let us see the corresponding quantum mechanical result, what Heisenberg proposes. So classical, let me write it again. Classical is xt equals summation tau c tau e raised to I tau omega n t, c tau equals c minus tau star for xt to be real. Quantum mechanically, we do not see xt, we do not see xt. That means I do not observe the trajectory. Therefore, what Heisenberg proposes, represent xt by collection of corresponding c tau and frequency tau omega n, which quantum mechanically are nothing but c tau is actually c n minus tau, that is the amplitude corresponding to transition from n to n minus tau level, and tau omega n is nothing but omega corresponding to a transition from n to n minus tau, which is equal to E n minus E n minus tau divided by h cross. So, I am not going to write an xt. So, quantum mechanically, do not write xt, but rather take its representation. And how are we taking the representation? So, given an xt, it is going to be represented by c n minus tau and the corresponding frequency omega n minus tau, which I have given what they are, and all n's and taus. This is how you represent. So, it becomes a collection of numbers, all right, and that is how you are going to represent. How are they observable? Because earlier I had said that he had formulated the theory in terms of observables. So, are they observables? Omega n minus tau is an observable because I see that is the frequency of radiation, and Cn n minus tau times 2 is the amplitude, and therefore mod Cn n minus tau square is proportional to the intensity. So, we are proposing two quantities, omega n n minus tau and Cn n minus tau, which represent the quantum nature of the system. I just want to note this is change at the kinematics level. That means kinetics is not yet decided. We just said kinematically this is how we are going to represent the quantities. How about the corresponding velocity? The corresponding velocity Vt, which is nothing but x dot t, which is d by dt of xt, is going to be represented by I omega n n minus tau Cn n minus tau and the corresponding frequency n n minus tau. How did I get this factor? This factor is because, let me explain again what happened classically. We had xt equals summation c tau e raised to I omega tau or tau omega n t. Its derivative x dot t is going to be summation tau I omega tau c tau e raised to I tau omega n t, and this is being replaced by this whole thing. So, we are making a correspondence with classical, but making changes that now any Fourier component of the motion is going to be replaced by a number corresponding to the transition from nth to n minus tauth level. So, we have representation of xt, which is a collection of numbers Cn n minus tau and the corresponding frequency omega n to n minus tau, which is equal to En minus E n minus tau over h cross. Mod Cn n minus tau square is related, in fact proportional to the intensity of radiation at frequency omega n n minus tau. So, this is a kinematic change that he has suggested, and all the corresponding other mechanical variables can be calculated. For example, we said that V tau is going to be represented by I omega n n minus tau Cn n minus tau and omega n n minus tau, right, and this comes because we are going to write. So, let me write this time dependence of Cn n minus tau is given as Cn n minus tau e raised to I omega n n minus tau t. This is taken directly from the classical result, and therefore, I could write Vt by taking the derivative. Similarly, I can write angular momentum or whatever. The next question that arises is, how do we multiply, add, subtract these quantities? In short, how do we perform algebraic operations on these quantities? And for that, Heisenberg was guided by how frequencies combine. So, first question, add the two quantities. Suppose I want to add x1t plus x2t, which also takes care of the subtraction. This will be represented by C n minus m for the first quantity plus C n minus m for the second quantity, and the corresponding frequency omega n minus m. The frequencies that I keep should be the same as those that I observe. So, addition and subtraction are taken care of. More important is multiplication. Suppose I have two quantities x t and y t. Now, these are represented by these numbers C n, let us call it x, n minus tau and omega n minus tau, and this is represented by, let us say, d n minus tau and omega n minus tau. How do I combine the two? So, classically, or in the classical limit using correspondence principle, what did we have? Xt is equal to summation C tau e raised to I tau omega n t, that is it. Yt will be equal to summation d tau e raised to I tau omega n t. I can also write this, the x, as summation alpha C alpha e raised to I alpha omega n t, and I can write y as summation beta d beta e raised to I beta omega n t, and therefore, classically xt times yt would be equal to summation alpha beta C alpha d beta e raised to I alpha plus beta omega n t. Is this how I want to represent it quantum mechanically also? So, let us see that. So, let us write the classical result. For xt times yt is summation alpha summation beta C alpha d beta e raised to I alpha plus beta omega n t. And this is not going to be in the case in quantum mechanically, because quantum mechanically I am allowed to keep only those frequencies that can be seen. So, any arbitrary frequency cannot be seen. For example, let us say if I have two levels, three levels, n, alpha, beta. If there is a transition taking place from n to alpha and n to beta, this will be the sum of these two frequencies, but I cannot see this frequency. The frequency that I can, however, see is the frequency omega n minus alpha, and one from this is n minus alpha, this is n minus alpha minus beta, and one which is omega n minus alpha to n minus alpha minus beta. I can see that frequency. So, what is known as Wright's frequency combination rule, according to which I can see frequency n minus alpha minus beta, which is summation of omega n minus alpha plus omega n minus alpha minus beta. Not all these frequencies can be combined. right? All the frequencies seen, this is sometimes also written in a cyclic form, which is omega n minus alpha minus beta n plus omega n minus alpha plus omega n minus alpha minus beta is equal to 0, what is known as Rayleigh frequency sum rule or combination rule. So, all the frequencies that are seen follow this rule. You can visualize this, that I see only those frequencies that come from combination of one level to the second level and from second level to the third level. I cannot combine frequencies arbitrarily. So, while writing this classical result in a quantum mechanics sense, I have to be careful. I can choose only certain combinations. So, let us see that. So, let me raise a question here. What does it mean that frequencies cannot be combined in a random manner? In other words, why the combination principle? So, as I said earlier, suppose I take many levels. The frequency that I observe cannot be, for example, I cannot observe this combination. If I take, suppose this is frequency omega 1, this is frequency omega 2, omega 1 plus omega 2 is not observed. So, I cannot take all the frequencies and combine them in any manner I like. What is observed, however, is this plus this, or second one, this plus this. So, they have to be combined in a manner that follows Wright's combination principle. Or you can say, I see one particular frequency where a total transition can be broken into two consecutive transitions. That is the physical way of visualizing it. Here I cannot break, for example, in the classical case, I cannot break, I am showing it on the left, the transition shown in pink into these two transitions, and therefore I cannot combine frequencies in such a manner. So, back to doing xt, yt. So, I should have only those frequencies e raised to I omega n minus alpha, let us say minus beta, which is nothing but e raised to I can combine them only in this manner, omega n minus alpha plus omega n minus alpha minus beta. This is the only way I should combine them, which makes sense because I can write omega n minus alpha minus beta, which is e n minus e n minus alpha minus beta over h cross as e n minus e n prime plus e n prime minus e n minus alpha minus beta over h cross, where n prime now could be any intermediate states. For example, again going back to this example, I will make these energy levels. Suppose this is my nth level. What I am representing this frequency omega n minus either like this, going up and coming down and all these things, but they have to be combined in this manner. And therefore, if I am combining frequencies like this, the corresponding, if I take C according to this, it will be C n prime, and this one for y would be d n prime n minus alpha minus beta, and therefore I should have xt yt. Suppose I want to get this term n minus alpha minus beta, this should be equal to summation all n primes c n prime d n prime n minus alpha minus beta, and I can write this as e raised to I omega n prime plus omega n prime n minus alpha minus beta t. So, we have done it in a very, very systematic manner, combining an experimental result called the Ride's frequency combination rule, and then really seeing how I could combine these. So, what we are getting is, therefore, I can write in general is x y some n minus tau component is going to be given by summation x n prime y n prime n minus tau summed over n prime. And in modern language, I know this is nothing but matrix multiplication. Multiplication of matrices x n prime and y n prime, the two matrices, and I am making their product. So, Heisenberg did not know matrix mechanics at that time. Physicists did not use them. He discovered this through this. So, which is another greatness. So, he has now shown that make kinematic changes in representing dynamical variables by observable quantities, and that means the amplitude and frequency of radiation observed. So, a quantity like x would be represented by, let me now write it, x 11, x 12 e raised to I omega 12 t, and so on. On the vertical side, x 21 e raised to I omega 21 t, x 22, x 23 e raised to I omega 23 t, and so on, where omega n prime is given as E n minus E n prime over h cross, and it could be negative or positive depending on what n primes are. So, all quantities are going to be represented by matrices, and the moment I say matrices, I also know how they should be multiplied. Consequence of this is that if I take x t y t, which is a matrix multiplication of x matrix and y matrix, it is not the same as y x. This we know from matrix algebra. So, this is not the same as y t x t. So, by this representation, it also follows that the normal commutative rule of multiplication does not apply to quantum mechanical representation. So, this is a big kinematic change from the classical way of thinking, that now x times v is not going to be the same as v times x, and this was a departure. And the rate of transition, or rate of energy coming out, which is the intensity from an atom, is going to be proportional to C n minus alpha mod square. Let us say this is for transition taking place from n minus alpha. If I could calculate C and omega directly, I have my answer, I have solved the problem quantum mechanically. How it is done, what are the quantum conditions, and how is the dynamics followed will be subject of next 2 lectures.